Hello, good evening all.
Good evening, sir.
Good evening, good evening. So let's get started. So I was just waiting. Maybe last time two of the people joined late. One of the people joined late and then came, so that's why I was just waiting. So let's get started with this session today. Uh, Welcome you all to this live session. This is the fifth session, fifth week of the numerical methods for engineers. I am teaching assistant from IIT Guwahati, working in the field of lithium ion batteries. So my expertise or the knowledge in the field of this numerical methods is can be helpful because I'm using it for my research purpose. So by that introduction, let's get started with today's week. So right now we are in the middle of the numerical methods, right? So last session, so sorry, this is a typo here. This is fifth now. This is a fifth week now. So last week we were studying nonlinear equations. We started nonlinear equation. So what is a nonlinear equation? Where the equation, the dependent variable has the variable has a nonlinear term inside it. So to solve those equations, we saw three techniques per se last time. So those were two bracketing techniques were there. Bracketing methods, and we saw one of the open method. So in bracketing method, we saw regular falsi and bisection, right? And in open method, we saw secant method, right? Anything else we did last time around? Ganesham, you were there, right? The last week. Yes, sir. So yes, this is the only thing we studied in the last time. So this week we extended our discussion, if we have gone through the lecture, to the fixed point iteration method, Newton-Raphson method, and Newton-Raphson is extended to the multivariable. So till now, till this point, it is only a single variable. That is either f of x is equal to 0 or f of m is equal to 0 or whatever. Here it's f of x1 comma x2 comma can be xn is equal to 0. In that case, in that case you have to use this numerical method called Newton-Raphson for multivariable. Now if you have a multivariable equation to solve, there will be always a system of equation. So let's say if I give you equation, let's say x1 plus x1 square plus 2x2 plus 3 is equal to 0. You cannot solve it with the one equation. You require one more equation, one more function, so that you can solve for x1 and x2. So number of equation will always be equal to how many unknowns are there. So here we see a system of equation in the class. Now if you want to see, so in bisection what we did, this was a x0, so let's say this is a bisection. Then this will be your f of x0, then this is your x1, and you just did an average of it, right? x1 plus x2 divided by 2, x0 plus x1 divided by 2. That's what you did, and you got an answer. Then in your regular falsi, and you did this x0, f of x0, this is x1, f of x1, and you connected a line to it, right? Sorry. Okay. Wherever it cuts the point, You said it is a x3 and extended it down to call it a f of x3. Again, you decided this is on the left hand side, so you connected these 2 points, right hand side, these 2 points. Now wherever it cuts, and you solved. Now these 2 methods are bracketing methods. And how did you kept these 2 solutions around the one actual solution? Is that you applied this, you checked for a negative sign, change in sign, right? You f1 into fl. So whatever your left hand side multiplied by the current multiplied by the current value, you checked what is the answer. If it's negative, then you changed, right? If the negative is there, then you replaced it with the XR. If the positive was there, you replaced it with the XL. So that's what you did here. Similar approach is there in a second method, but where there we don't consider these 2 things. We are not bothered with the what are XL and what are XR. Without it, we are just going with the whatever the value we get. We just go into iteration. So that was a brief overview of what we did. Now Newton-Raphson fixed point iteration method, what it does is, in fixed point iteration method, we find one initial root. That initial root we will consider, and in fixed point means that's fixed point is what is a root, right? So we just guess one root, and with that guess one root we go on iterating with the formula. So the formula goes like, so whatever your f of x is given, you will put your value inside it, and you will try to find what is the solution, and then go on repeating it. So before going to that, we will find what is, so we will see through how to solve the numerical. You will get a better understanding of solving this through what is fixed point Newton-Raphson and multivariate through numerical. So before further ado, let's get started with this. So first question is, consider the following function f of x is equal to x raised to 2.5 minus 12 x raised to 1.5 minus 20x plus 120. Find the value of x after 4th iteration. So what you will do, so you find a one, so this f of x can be written in different forms of x, right? So what you will do, so one can do is, you have to find a x out of this, right? So one can do is, so you will consider f of x equal to 0, which implies x is equal to 5 minus 12 x raised to 1.5 minus 20x plus 120 is equal to 0. So I can take this 20x to the different other side. So 20x is equal to x raised to 2.5 minus plus 12x, sorry, minus 12x raised to 1.5 minus plus 120, right? And divide by 20. So this is 1 divided by this is the one way of writing it, right? This you will call another function g of x. Other way of writing it would be taking this 2.5 to the power, right? So what we can do is, we keep this, so this is can be a case 1. Other way, case 2 could be, we'll keep this 2.5 in this side, and then 12x 1.5 minus plus 20x minus 120, right? So the x would be 12x raised to 1.5 plus 20x minus 120. So 2.5, 1 divided by 2.5 is 0.4. So this can be of g of x, this can be your g of x. You will find the root of it and iterate on this equation again and again. Now which one to choose, this one or this one? So in the class lectures, if you say, sir, already started with the one initial guess. So what actually we have to do is, first we will find out where that root of the equation lies. So first we will just put f of 0 in the equation. First we will see in which interval the solution lies. So f of 0 would be, if this is f of x, okay, so f of 0 would be 0 minus 0 plus 120, that is 120. This is positive. F of 1 would be 1 raised to 2.5 minus 12 into 1 raised to 1.5 minus 20 into 1 plus 120. What is the answer? It will come out to be 89. So this is positive again. Okay. F of 2 would be 2 raised to 2.5 minus 12 into 2 raised to 2.5 minus 20 into 2 plus 120. So this value comes out to be 51.71, again positive. So you know the drill. Now f of 3 would be, again if you put 3 into it, you will get 13.23. F of 4, can you somebody tell me f of 4? 4 raised to 2.5 minus 12 into 4 raised to 1.5 minus 20 into 4 plus 120. Anybody there? Minus 24, right? So here it is negative, it is positive. So there is a sign change between f3 and f4, right? Implies root or solution lies between 3 and 4. Okay. So let's consider one point between 3 and 4. Therefore, let's take x naught, that's the initial guess, as 3.5. Now what we have to do to check, sorry, to check which g of x to consider. First we will do is take g of x, perform first derivative of x, of that function, and put it at a 3.5, or we can say g of x is equal to 3.5 and check its sign. If it's if it's less than negative, that is, if it's less than 0, then you consider it. If it's greater than 0, you reject it. So for the first function, g of x is 1 by 20 x raised to 2.5 minus 12 by 20 x raised to 1 by 5 plus 6. What will be g of x? G dash of x, 1 divided by 20, 2.5 divided by 20 is 1 by 8 x raised to 1.5 minus 18 divided by 20, right? It is 0.9 x raised to 1.5 plus 0. So now g dash of 3.5. So 1 by 8 3.5 raised to 1.5 minus 0.9 into 3.5 raised to 1.5. What will be the answer? Hello? Yes, so it is 5.074, that is negative. So we can consider this equation, that is this g of x. Just for a completion sake, let's say case 2 is what? G of x is equal to 12x raised to 1.5 minus 20x plus 120 raised to 0.4. What is the g dash of x? It would be 0.4 into 12 into x raised to 1.5 minus 20x plus 120 into 12 into 1.5 is 18x raised to 0.5 minus 20, right? So g dash of 3.5, what do you get? So put 3.5 here. This is minus raised to 0.6, right? 0.4 minus 1, so it would be minus 0.6. This will come out with 0.296, which is positive. So since this is less than 0, we will consider this. Okay, so now you have iteration 1. For that, your initial guess is 3.5 and g of x is 1 divided by 20 x raised to 2.5 minus 12 divided by 20 x raised to 1.5 plus 6. So it's simple. x1 would be, you just put x1 value here, that is your x1. So 1 divided by 20 into 3.5 raised to 2.5 minus 12 divided by 20, 3.5 raised to 1.5 plus 6. What you will get? Yes, 3.27217. It's better you consider one more, 3.271. Now for iteration 2, x of 0 is, x of 1 is 3.2171 and x of 2 would be 1 divided by 20, 3.2171 raised to 2.5 minus 12 divided by 20, 3.2171 raised to 1.5 plus 6. Therefore x, second iteration of x is yes, 3.4659. So till what iteration it is? A fourth iteration. So iteration 3, x2 you x3 directly as right, okay, x2 is there only. 1 divided by 20, 3.4659 raised to 2.5 minus 12 divided by 20, 3.4659 raised to 1.5 plus 6. You will get answer. Then iteration 4, x of 4 would be 1 divided by 20, whatever answer you get, raised to 2.5 minus 12 divided by 20, get raised to 1.5 plus 6. Okay. So what is x of 3? So I have made a Excel sheet like a previous class, so we'll better see it there. 3.2467. Yeah. So that is your third iteration. No? Fourth iteration would be one more. You have to full it. This is 3. Are you able to see? The Excel sheet is visible to you, right?
No, sir.
No?
Yes.
I'll first. Again, I have shared, okay. So here I have started with this. The sheet is visible. Sheet is visible, right?
Maybe not working in mobile, sir.
Okay. Now? Okay, let's go ahead. It's visible to few of you, so let's go ahead. So here I have considered this x0 that we got from the study of the where the solution we determined the interval in which it should lie, and from there we got this just the solution that I have, the equation that I put, and just considered the function there, and we got the value. Then that value is been assigned here, and similarly the rest of the table has been produced. Here the error is calculated by taking absolute of difference between these two values, and just using drag and drop I have calculated the rest of the table. So here you will see your all the x values, and if you go down, the error is reducing as you go with your iterations. So by the fourth one, this one was the value that was asked in the numerical, and you get about, so this is up to 10 raised to minus 3% error. So this is where you can stop and say, okay, this is considerate value 3.349, and this is your solution of the equation using fixed point. Now let's do this study using Newton-Raphson method, right? So for Newton-Raphson in numerical 2, third iteration, right? So in Newton-Raphson, you just have to see if the function has the function's first derivative. So in Newton-Raphson method, so if the concept wise it is, you consider first x1 fx1, if it's 0 0, sorry, then you consider a you consider a slope to this, it will cut at some point, right? This will be your x1, and this is your fx1. Again you will take this as a point, and then again take a slope here. So this is, if you take this in this one, this will be here, this is your x2, and this is your f of x2. Okay, so find the value of x after third iteration using Raphson method. So if you see its formula easily, that tangent, that slope formula for the equation of line, it is x of I minus f of xi divided by f dash of xi. So what you require the current x value, its function value, and its value for a first derivative, right? So this one you will have, this one you can calculate, and for this one you have to take the first derivative. So the function f of x is x raised to 2.5 minus 12 x raised to 1.5 minus 20x plus 120, f dash x 2.5 x raised to 1.5 minus 12 into 118 x raised to 0.5 minus 20, right? So it's f dash x is not 0, so we can go ahead with using Newton-Raphson's method. If f dash x is 0, the equation itself fails, right? Hence you cannot use this value even the function value is 0, derivative will be 0, and first derivative will be 0, it will be a constant. That is why when the slope when this thing comes like this, the function has this kind of a dip, or if you go at this point and you try to find a tangent, it will be like this. So there it will have some problems. So constant value and function zero value you cannot solve. So we'll go further with this equation. So for iteration 1, again you will have to do the similar thing. If we have given initial guess in the exam, you have to consider that. If you have not given the initial guess, again you have to follow this procedure. You will put f0, f1, f2, f3 and see where the solution, where the function is changing its sign. In between those, you consider any value. So here I have considered 3.5. You could have considered 3.3, 3.4, and it would have worked as well. So here I'm not again calculating those things. Previous question. So this was the previous question. Okay. Okay. So in this, I have calculated this value, and we got to know that the solution lies between 3.3 and 4, and that's what we got also from the Excel sheet. It was somewhere around 3.9 or something, right? So iteration 1 would be, we know x naught would be, I am considering 3.5. So therefore, using Newton-Raphson method, x of 1 would be x of 0 minus f of x of 0 upon f dash of x of 0. Now f of x of 0 is is all 0 and plus 120. This is 120. F dash of x of 0 is 0, 0 minus 20, implies x1 implies x of 1 would be x0 is 3.5 minus f x of 0 is 120 divided by minus 20. So this is 6, right? So 3.5 plus 6. Oh, I have considered it as 0, right? It's 3.5, no, not 0. F of 3.5. 3.5 raised to 2.5 minus 12 into 3.5 raised to 1.5 minus 20 into 3.5 plus 120. F dash of 3.5. Sorry, my bad. Considered I considered 0 at first. It is not 0. It is not starting at a 0, right? Our initial guess is 3.5. So you have to put those values and get an answer. So this would come as 5.6572, and this would be 37 point minus 37.305. So now you have all the values. You can put x1 would be x of 0 is 3.5 minus 5.6572 divided by 37.305. 37.305. So you will get x of 1 would be 3.3483. This is your first iteration. So after third iteration, right, this is your first iteration. For iteration 2, so also, okay, I'll show it at the end. Iteration 2, x1 you have, f of x1 you can calculate. So f of x1 would be 3.3483 divided interest to 2.5 minus 12 into 3.3483 raised to 1.5 minus 20 into 3.3483 plus 120. This is minus 37. Okay, that is previous one. What is the value here? Would be 0.02436. If dash of x1, sorry, x1 3.3483 2.5 interest to 1.5 minus 18 3.3483 raised to 3.5. This should be 0.5, right? Minus 20. That is 37.6199. Therefore x2 would be, now you must have got an answer, 3.3483 minus 0.02436 divided by minus 37.6199. Yeah, 3.3490. So iteration 3 you know. Can you tell me the answer, final answer? Here again the same thing, you'll have to do f of x2, put the value, you will get 4.1 into 10 raised to minus 7. F dash of x2 would be minus 37.619. Therefore x3 would be x2 minus f of x2 divided by f dash of x2. So x of 3 would be again 3.349. So you get an idea here. This value we got with the fixed point iteration after, let's say, okay, I'll just share that Excel sheet, then you will, it's going to be better for me to tell you, right? If you see here in the fixed point iteration, we got an answer after some 64 iterations, right? The same answer we got it from the Newton-Raphson method at the third iteration or a fourth iteration itself. So, and the error is also 0 after each iteration. So Newton-Raphson method gives you the fastest convergence. Just there are 2-3 problems with the Newton-Raphson method. Like I said, if the derivative of function is 0 or if the slope of the function is going constant, then that time you will have a problem solving this. Then that time we give the addition slope to this. So now we will go for the third question. So let me just stop my sharing from there and get it from here. Okay. So the next question is this question we saw using, I guess, regular falsy method we solved in the last class. Now in this class we are solving it using Newton-Raphson method. So first what we have to do, first we have to check what would be the first we have to check what would be the function of v, function of, so what we are trying to find out, m, right? So first we have to find out the function of m, then after finding out the function of m we have to take its first derivative, and further we can do by solving the putting the initial guess and iterating it further and further. Now here it has given you the initial guess is 60, so it is just your duty just to find out the correct solution, value of correct function for function of m. So how will you find out that? There are 2-3 ways. One way is just taking this thing to the other side. Other way one would do taking log and everything. So I'll just do the easiest way. So V is equal to Gm divided by C, 1 minus now what you will do? After this one, is here V into C. Correct, right? This is a function of m, right? E raised to that's exponential is there, right? Okay, negative. So now I'll just put the values here. That's it. V is your 35, C is 50 divided by G is 9.81. Correct. Go ahead and then solve the solution. It will be easy. So first what we will do? First f of m, that is 35 into, I'll get my calculator. Into 15 divided by 9.81, 53.51 into 1 divided by 1 minus wait a second. Okay, actually I have to write it as a fixed point. So this is what we are doing as a fixed point. Okay, we'll see how to do it using a Newton-Raphson, because if you for a fixed point only, you can write it as this. This is a g of m, and then you can solve. So this is a g of m here. In normally this is a for Newton-Raphson, you have to consider f of m, and then you have to directly take a function of directly f dash m here, and f f of m would be, so this is fixed point. So first we'll see the fixed point and then we'll go for a Newton-Raphson method. Okay, so this is g of m, 53.81, 15 minus 15 into 9, so minus 15 into 9 minus minus 135 divided by m. So this is your g of m, right? So you have got, for first iteration you just need these two values. You have a g of m, and now you have an initial guess, and then you can go for the solution. Correct, you are going correct. The third one, so you got to go till third iteration, right? Velocity is velocity, so they have not given anything, so try to solve it till at least the second iteration will go. M of 0 is given 60, right? So g of m of 0 . that is 59.822. Iteration 2 would be m of 0 60. This is m of 1, no? So here it would be 50. You consider this 2 m of 1 53.51 my into 1 divided by 1 minus e raised to minus 135 divided by this 59.822. So this would be 59.7626. Okay, that is the third iteration. Okay, correct. So for the second iteration you will get 59 point, second iteration 7.775 g of m of 1. So this is g of m of 1. It is a, so this g of m of 0 you will consider it as a m1 for the next iteration. Then it is m of 2 and you repeat it. Now I said for a Newton-Raphson method, right? So Newton-Raphson. In Newton-Raphson, first you need a function of x, or here you will require first function of m. Then because you are finding out function of 0, since we are finding out mass, right? Then for function of m of is equal to 0. So here you will put the x0 m0 as 60 in the both cases, and then you will use the formula m of I plus 1 is equal to m of I minus f of m of I divided by f dash of m of I. Okay, so your function, this is a v into g by m divided by c, 1 minus e raised to minus c by m into t. Okay, so the function of m would be, just we have to take v to that side, g of mc 1 minus e raised to c by m into t into v. So f dash of m, so you have to use the uv rule here, okay, and get an answer, because there is a m here and m here, so you will have to use uv rule. So you can do this Newton-Raphson method by yourself. I just showed you the fixed point method. So let's see again the Excel sheet to get a better understanding how the both of the methods are working. So entire screen. So this is how it is. This is what we did, 60. Then this is your g of m of I, where 30, I just put the function here, right? And that value we will consider as a m for a next solution, next iteration. And again the fixed point iteration converge really fast here. You can say your answer came into the 10th in the 6th iteration or of 7th iteration itself. Okay, so this is your answer. So when I'll share the Excel sheet, I'll add the Newton-Raphson method solution for you, and then you can cross check. So we'll go for the next one. Next is your next is for fifth question, right? Fourth question. question is, consider the following set of two nonlinear equations. So now we are talking about two nonlinear equations. So this is a multivariable, not because it is having a two nonlinear equation, because it is having a two variables. Since there are two variables, it is imperative that it will have a two nonlinear equations. Okay, so to solve this, again you are going to use a Newton-Raphson method. So here it has said Newton-Raphson method after second iteration. So for this, what we have to do, there you just considered a uh, the equation when there was a single variable. Now since there are two variables, we are interdependent on each other. We have to use a partial differential equations and check the interdependency. So the Jacobian is the one way which gives the interdependency between each of the variables. Now here are only two variables, that is why your Jacobian would be 2 by 2 matrix. When there would be three variables, the Jacobian would be 3 by 3 matrix, and so on. So for n variables and n equations, you will have a n by n Jacobian. Accordingly, the rest of the things are the same. So first you will have to find f of, so x, initial guess is not given to you, what? So is the initial guess. Let me check. Okay. Because here you cannot use this f0 f1 because your interdependency that is here there. So I'll just see if I have this yeah. So x naught is 1 comma 2, this one. So what does it mean? This is your x1, this is x2. Okay. The thing goes the same. Again you will find the solution f of x naught, right? So there are two equations, right? So it will have a f1 x. So let's call these two equations. So f1 of x is equal to x1 plus 2x2 minus 2. f2 of x is equal to x1 square plus 4x1 x2 square minus 4 is equal to minus 4. So there what we did, first you found out the values of x function at the given initial guess. So same here, f1 of x naught, that is f1 of 1. So 1 plus 2 minus 2, that is 1, right? Sorry, 2 into 2. So x2 is, this is 1, this is 2 minus 2, this is 1 plus 4 5 minus 2 3. f1 of x0 f dash of, so this is 1 square plus 4 into 4 into 2 square, okay, 4 minus 4. So this is 1 plus 12, that is 30. So this is what you get. So this is again equivalent to your function value that you got here, right? So function values that we calculated in Newton-Raphson, in the second equation, Newton-Raphson you calculated first. Second one is you have to calculate the derivative. So rather than calculating derivative, what we do is we calculate a Jacobian. So that is a J. The Jacobian would be first your derivative with dou f1 divided by dou x1, dou f1 divided by dou x2, dou f2 divided by dou x1, dou f1 divided by dou x2, dou f2 divided by dou x2. Let me just be sure with it. No. So the first column, first column is related to x1 only, second column denominator x2. That's it. So what would be dou f1 by dou x1? This is 1 minus 0 minus 0, so this would be 1, right? Then dou f1 by dou x2, so for function of this one, this would be 0, this is what, 2 raised to this thing, 8x, right? Function, dou f1 divided by dou x2, so for this function you are talking, right? So 1 dou x2, so that would be 2, here dou f2 divided by dou x1, so for dou f2 dou x1, 2x1, this rest of the part is 0, 2x1, then this for this dou f2 divided by dou x2, this is 8. So for this you have to calculate with respect to x2, this will be 0, this is 8x2, and this is 0. So this is the Jacobian you have. So here what you did, for the function value you put the value of, that one is x0, function at x0 and f dash at x0. Similarly, function at x0 that you have done, function at x0 that you have done. So rather than writing this as a, write it as f1, f2, f1 and okay. So this one you have done function values, okay. Now for a Jacobian also you have to find out at x0. So again it is a whole combined Jacobian. So here only you will find j of 1, 2. So 1, 2 will be constant, 2 into 1, 2, 8 into 2, 16. This is your j of x0. Okay, this is your Jacobian. So here how you calculate the value is, next value x1 is x naught minus j inverse of x naught into f of x naught. So here you have x naught already, that is, this is 1 comma 2. F of x naught also you have calculated 3 oblique 13. You have calculated 3 and 13. You just have to calculate this j inverse of x naught. You have a j, so j inverse is easy, right? This value is 16, 1 minus 2 minus 2. So for 2 by 2 inverse is like this, right? So 16 minus 2 minus 2 1. This is your x1. And here you have to multiply by its determinant, no? So this is determinant of j. So det j is equal to 16 minus 4, that is 12. That I have put it here. So 12. So 1 by 2 minus 1 divided by 12 into, so this is 16 into 3 minus 2 into 13 minus 2 into 3 plus 1 into 13. So what is your final answer? x1 1 by 2 minus 22 divided by 12, 7 divided by 12. So this is minus 0.8333, 1.41667. So with this initial guess, again you will, so for iteration 2, what you have, this is your x1 x2 values. You will calculate what is f1 of x1. f1 of x1 is equal to what, f2 of x1 is equal to what. Then we will calculate Jacobian. Then for after calculating Jacobian, this remains same, 2 entries. This remains same, in which you will put x1 is equal to this value, x1 is equal to this thing. And x2 is equal to this 1.41667. This you will get x1, you will get the value from here, and again you will take its j inverse of x1, and after that you will get in the final equation, this equation, x2 would be x1 minus j inverse x1 into f of x1. Okay, so this you will iterate again and again. Only thing is, function values you have to calculate. In Newton-Raphson, what we do is, first function values f of x, second derivative or Jacobian depending upon what you are doing, and third formula. That's it. the steps remains the same. Just as you go with the number of system increases, your Jacobian size will increase, and number of times each time you have to calculate this f1 how many functions you will have. So for a three equations, three unknowns, you will have f1, f2, f3. Jacobian would be j, this would be like this: dou f1 divided by dou x1, dou f1 divided by dou f2 divided by dou x1, dou f3 divided by dou x1. Similarly, dou f1 divided by dou x2, dou f2 divided by dou x2, dou f3 divided by dou x2, and similarly dou f3 divided by dou x3. Okay, so you get an idea, right? So this 3 by 3 matrix you will have, again initial case you will have 3, and same goes. So I have done this for share screen. If you can see, this is the Excel sheet. Okay, so x1, x2, this is a one vector we have. Then this 3 and 13 we calculated from that. Then Jacobian 2, Jacobian 3, Jacobian 4, 1, 2, 2, 16 for a first one, putting that values. Then determinant I have calculated. From that, here using the values in Jacobian, I have Jacobian values I calculated. I am calculated x1 and x2. So these two values we got. Similarly, if you calculate for further, and here I am calculating error. So error would be, so similarly these x1, x2 values directly this x1 value is taking as a first iteration here, second x2 is here. Using them again I am calculating the rest of the second iteration. Again the error would be the absolute difference between the consequent values you get. For x1 it would be different, for x2 it would be different. And if you see, the error goes below e raised to minus 5 at the 48th iteration. So these two values you can consider for as a solution. So this is how you can go about it. I will share this thing with you so that you guys can again look into it when your time permits you, right? So I'll share my Excel sheet. So from there you can again see the solutions. We'll cross verify. Now we have two more equation solutions to go. So for fifth one, are you able to see my screen? Are you guys able to see my screen?
No, sir. No, sir. Very confused. Oh, now.
Okay. Maybe there is some lag. Yeah. Yeah. So this is the fifth question. So there is one more. So I'll just. This is very easy. You are designing a spherical tank to hold water in a small village in a developing country. The volume of a liquid it can hold can be computed as this. The V, H, R, the V is a volume, H is a depth, R is a tank's radius. If R is a 4 meter, to what depth must the tank be filled so that it holds a 40 meter cube? So this is meter cube. Use 3 iterations of Newton-Raphson method. So for Newton-Raphson method, what you require? So Newton-Raphson requires, so whatever you ask for, so here at what depth? So depth is given by H, right? So you will require a function of H, f dash of H, right? And H naught. So take initial guess is equal to 1, that is equal to x0, that is equal to 1. So function of h. Now how you will calculate the function of h from here? So what you have given, v is equal to function of h. I am not saying g of h. I am saying function of h, f of h. G of h is for this thing, fixed point. Function of h is, we will get like this. V is equal to pi h square, right? 3r minus, I'll write first, okay? So from here what you get? 3 pi r h square divided by 3 minus pi h cube divided by 3. Therefore function of h would be, if I take a v to that side, it becomes a function of h only, right? 3 pi r h square by 3 minus pi h cube divided by, so this 3 gets cancelled, and so this is your function of h. So I will put the values. R is 4 and v is equal to 40. So r is 4, right? So 4 pi r h square minus pi h cube divided by 3 minus 40. So this is your function of h. F dash h is equal to Ganesham, you saying no? Acha, that is for the previous one, okay. So f dash h is equal to, just I have to take a respect to h, 8 pi r minus 3 will get cancelled, so pi h square minus 0. So this is not required. Right? FH, you have a f dash h, right? So you have h naught, this h naught. So iteration 1, f of h naught first you will have to calculate, right? F of h naught is what? 1, right? 4 pi, sorry, r I didn't put. So 4 pi r is what? 4 pi, 4 is 16 pi. Oh, sorry, 4 pi h square, and this is 8 pi. R I had put. So this is, I had put the value of r here, then I got this value and took its derivative to get this value. So f of h is equal to f of 1. So 4 pi minus pi by 3 minus 40, f dash of h0 is f dash of 1, 8 pi minus pi. So whatever value you get, so what's the value? This is minus 28.4808. Here you will get 21.9911. Therefore h1 would be h0 minus f of h0 divided by f dash of h0. h0 is 1 minus f of h0 is minus 28.4808 divided by 21.9911. So what is your h1? What is h1 value? Yes, 2.29510. So similarly you will iterate for the solution. So it has asked you determine the answer only. So I'll just, you can do it at your own pace at your home. I'll just show you the Excel sheet from where you can get a hang of it. So entire screen again. Okay. So if you go tank, so this is by Newton-Raphson, that tank question I am solving. We started with the first solution. This one I had just put the equation here. Then for the equation of derivative, put the value of 1 here, you got the answer. Then using the Newton-Raphson formula, I got this value. Then similar thing is procedure is followed, and after fourth iteration only the error is getting in the e raised to minus 5, and it's becoming 0 after fifth iteration. So you can see how quickly it is converging here. Whereas if you solved it using a fixed point, so in fixed point what would happen? So in fixed point if you go, so before starting I'll just show you fixed point when it is converging. So if you see the fixed point giving you the 1.9494 answer which you got here in the fourth iteration at 48th iteration. So for a fixed point you have to calculate first the g of m, right? So that would be different from f of m. So g of m is nothing but we write this function. Sorry, not g of m, g of h here, right? So we write this function in terms of h only, but take one h at a one side. So here one way of writing it would be, so what is a function for fixed point? What is a function? We started with v is equal to pi h square 3r minus h divided by 3. One would take this h square this side and the h square one side and take raise over that side. So h square would be 3v divided by pi into 3r minus h. Therefore h is equal to under root 3v divided by pi into 3r minus h. This can be your g of h. Other way someone else can take is you can take this h to the one side and get a value. So there are different methods to get a g of h, and because there are two different methods, which one to consider, that you will see how. First, in the function you have given, you will find the solution. So with the initial, if the initial guess is given to you, you will take that initial guess. So here the initial guess was given to you, right? Initial guess was 1. So with that initial guess, what you will do, you will kind of f of 0, you will find out the g dash of h. G dash of h you will find out. After finding g dash of h, you will put it at, you will put it at h is equal to h0, that is 1 here, and see its value. If it's negative, if it's less than 0, then the fixed point will converge. Otherwise, you will see for a different one. So for this one, if you take its derivative with respect to h, so here what you will get, g dash of h, you will get 3v divided by pi is constant, so it will be 1 divided by 3r raised to minus raised to 2, right, into derivative of this. So derivative of this is minus 1. Is it correct? So here what you will do is, you will put the value of v, then you will get this 120 pi so this will be minus 31.30. So since this is negative, you can use this. So this is the way you can follow to solve the fixed point iteration. Even in Newton-Raphson we have seen. Now one last point is how to solve it use the real root of equation. So here also using a fixed point iteration method. So what I said, for a fixed point iteration method, first you will need an initial guess, right? This is your f of x. So initial guess, how you will calculate? F of 0, this is minus 1. F of 1 would be 1 cube minus 1 square minus 1, that is 1 plus 1 minus 1 is equal to 1. So this is negative, this is positive. Root lies between 0 and 1. So let's initial guess, take x0 is equal to 0.5. Now case 1 would be of g of x. So g of x can be written as, so we have x cube plus x square minus 1 is equal to 0, right? So here you can take x common, x square plus x minus 1 is equal to 0. X square common also you can take, right? First we take x square common, then x plus 1, it's x square. Therefore x square is equal to 1 divided by x plus 1. Therefore x is equal to 1 divided by x plus 1. This is case 1. Case 2, x x cube plus x square minus 1 is equal to 0, right? So what you can do, uh, this is the first, I can directly take this x square to the that side, right? So x cube is equal to 1 minus x square, therefore x is equal to 1 minus x square raised to 1 by 3, correct? This is also one of the method, and case 3 would be x cube plus x square minus 1 is equal to 0, therefore x square is equal to 1 minus x cube, therefore x is equal to 1 minus x cube raised to 1 by 2. Now what we do, we take this as a g of x, we consider this as a g of x separately, find its first derivative. So here g of x would be, so for case 1, g dash of x is equal to 1 divided by x plus 1 raised to minus 2, right? So it's equal to 2. This is your g of x. No, raised to minus 3 by 2. Right? So this is how x plus 1 raised to 1 by 2, right? So 1 by minus 1 by 2. So if you get this thing, this can be written as this. This is the first one. So you will put g dash of x is equal to 0.5. So you have considered x naught is equal to 0.5, right? So g dash of x0 is minus 1 divided by 2 into 0.5 plus 1 raised to 3 by 2. This is minus 2721. Okay, so this is negative less than 0, therefore convergence is possible, or convergent. Okay, now for case 2, let's see what happens. So case 2 is this thing, right? 1 minus x square raised to 1 raised to 3. So x is g of x is equal to 1 minus x raised to 1 by 3. Therefore g dash of x is equal to 1 by 3 x raised to square minus 2 by 3 into minus 2x, right? Therefore g dash of x is equal to 0.5 with g dash of x0. If you put the value of 0.5 here, you will get minus 0.403, which is again negative, implies convergence is possible. Case 3, g of x is equal to 1 minus x cube raised to 1 by 2. Therefore g dash of x is equal to 1 by 2, 1 minus square, 1 minus 1 by 2 is equal to 3 by 2, right? 1 minus 1 by 2 is 1 by 2. Into minus 3x square. To g dash of x is equal to 0.5. Again you will check. This is comes out to be minus 4.00. So again negative convergence is possible. So here also convergence is there, this is also convergent, this is also convergent. Now in this kind of a situation, which one to go for? In this kind of situation, you will always consider the value which will be near to the 0. So this value would be near to the 0, right? These are far further away. So this is farthest, this is second, and this is the first, right? So for this one, whatever the g of x is there, that we will consider. That is why we will consider case number 1. So with case number 1, you know the drill now. So with the case number 1, you can always calculate what is a x0 also you have. So I'll just write down the first iteration. So iteration 1, x0 is 0.5, that we found out, and g of x is equal to this one, 1 divided by under root x plus 1. Okay, therefore x of 1 is equal to 1 divided by under root 0.5 plus 1. .8165. So this is your x1, and again you will proceed. So this is the discussion I have wanted to have with respect to the numerical methods related to nonlinear equations. So for here we conclude our nonlinear equations topic. Last week we discussed about bisection method and regular falsi. Those were a bracketing method. Then we talked about secant method. Today we continued with those were the starting of the single variable problems. Today we concluded with continued with this fixed point iteration and Newton-Raphson's method. We saw where Newton-Raphson's method failed, how to select the initial guess for a Newton-Raphson as well as fixed point iteration. So if you have given initial guess, you will use that. If you have not given initial guess, you will find out the value of a function, and you will see where the change of sign is there, and that will be your interval. In case of a fixed point iteration, you have to check if the function will converge or not, because it can also diverge if you considered equation is not correct. So how to check that? We will first we'll first rewrite into the form of g of x, right? From g of x, you will take its first derivative, and the value of the initial guess that you have considered. If the initial guess value of the function's value at that initial guess, derivative of function's value at that initial guess is negative, then that function you will consider to solve the solve the fixed point iteration. In numerical methods, you will have to just consider if the slope of the equation is the slope of the equation is not going to 0. That you have to consider, otherwise you cannot use the numeric the problem. So this was all about the numerical methods for nonlinear equations. If you still have any doubts in this session also, if I have gone fast or somewhere I have just gone skipped something and you have not understood, then please post it on the Google forum. I will address your queries there. So if you don't have any queries now, then we can conclude the session. Any queries?
No, sir.
Okay. So please write your queries on the Google forum. That is easier for me to give you feedback then and give you solution then and there. Okay, we'll meet next week same time. Okay, good night. Thank you.
Good night, sir. Thank you.